Welcome back everyone to Chemistry Made Simple for NEET. I am Dr. Subramaniam with a PhD in Chemistry. So, I just want to start with mentioning one important point here, that most of the students usually find organic chemistry as the most difficult section in chemistry, and they often ignore organic chemistry thinking that it would be difficult to study. Though the fact that chemistry is a difficult subject remains true, you can make the most out of it if you understand and study the concepts. Chemistry can be studied at ease if you know the actual technique of studying it. So, already I have uploaded many lessons from class 11 as well as class 12 and MCQs, the most important MCQs from those lessons. Along with that, I have added simple tricks to solve many situations, many tough questions, as well as mind maps of a few lessons. I will be continuing to upload all the lessons from class 11 and class 12 also, along with the most important MCQs of the portions. Now today we will move on to the MCQs here. That the first one is, who introduced the concept of hybridization? So the choice is A. Pauling, B. London, C. Sidgwick and D. Alexander. So the option is A. Pauling. So in order to explain bonding and shapes of every polyatomic molecule like methane, carbon tetrachloride, water, boron, etc., it was Pauling who introduced the concept of hybridization. Okay, the next question is, the phenomenon of forming completely new atomic orbitals by intermixing them is known as A. Allocation, B. Hybridization, C. Chemical bond formation and D. Electronic configuration. Choice is option B, hybridization. You know what is the exact meaning of hybridization? That is the mixing up of different orbitals to form a new set of equivalent orbitals, otherwise it is called as hybridized orbitals. These hybrid orbitals are used in the formation of bonds. Okay, coming on to the next question. The orbitals that are resulted from sp hybridization have dash % of s character and dash % of p character. So, is it 25-75, 75-25, 20-80 or 50-50? Answer is option D, 50-50. Because when one s orbital and p orbital undergo hybridization, two sp orbitals are formed. One sp orbital has 50% s character and 50% p character. They have a linear geometry, and so they are also known as, it is also called diagonal hybridization. Okay, next question is, in BCl3 molecule, what type of hybridization does it undergo? Is it sp, sp2, sp3 or sp3d? Option B is the correct answer, that is sp2. Because if you take the case of BCl3 molecule, one s orbital and two p orbitals intermix and they form three equivalent hybrid orbits. So it undergoes sp2 hybridization and forms trigonal planar shape like B in the center and chlorine will be in the three corners. Hope you understood this. Now what is our next question? What is the bond angle of HCH in methane molecule? Is it 104.5 degree, 109.5 degree, 108 degree or 120? Option B, that is 109.5 degree is the correct answer. What is the explanation for this? Because in methane, CH4 has undergone sp3 hybridization, that is 1s orbital and 3p orbitals will combine to give 4 sp3 orbitals. So it shows tetrahedral geometry. What happens here is that the angle between the bonds of corner atoms and the central atoms is 109.5 degrees. Okay, now the next question, what is the number of sigma bonds in ethene molecule? Ethene is an alkene. Is it 6, 7, 4 or 5? Answer is option D, 5, because the formula for ethene is C2H4. So, one sigma bond is there between two carbon atoms and two sigma bonds between each of the carbon and hydrogen. So, totally there are 5, that is one pi bond is present between the two carbon atoms. Okay, what are the types of orbitals that undergo hybridization in order to get octahedral geometry? A, s orbital only, B, s and p, C, s, p and d. Option D is d orbital and p orbital. The answer is option C, s or s, p as well as d orbital. Because you know, in as far as octahedral geometry is concerned, it is possible only when the orbitals undergoing sp3d2 or d2 sp3 hybridization only. So it involves one s orbital, 3 p orbitals and 2 d orbitals. So example of this is SF6. Okay, now What is the geometry of PCl5 molecule? Is it square, pyramidal, V-shaped, trigonal, bipyramidal or tetrahedral? The answer is option C, trigonal, bipyramidal. Because you know in PCl5 molecule when it undergoes sp3 hybridization, it possesses the geometry trigonal, bipyramidal. In the shape, the central atom is phosphorus and the atoms at the 5 corners are chlorine. So remember how this is formed, that is in the PCl5 molecule. Okay, come on to the next question. Which of the following statement is true regarding hybrid orbitals? 4 options. First one is the amount of orbitals formed after hybridization is not equal to the number of orbitals before hybridization. B, hybrid orbitals don't have equal energy. C, they can form more stable bonds than the pure orbitals. D, hybridization doesn't indicate geometry. The option C is the correct one. They can form more stable bonds than pure orbitals. Because the true statements of the incorrect ones are the number of orbitals formed after the hybridization will be equal to the number of orbitals before hybridization. So, hybrid orbitals have equal energy and the hybridization shows geometry. Okay, the combination of 2 atomic orbitals results in the formation of 2 molecular orbitals, namely A, 1 bonding and 1 non-bonding orbital, B, 2 bonding orbitals, C, 2 non-bonding orbitals, D, 2 bonding and non-bonding orbitals. The correct option is A, 1 bonding and 1 non-bonding orbital. See, Hunt and Millikan, they both proposed molecular orbital theory, MO theory, in the year 1932. So, according to this theory, when 2 atomic orbitals combine, it results in the formation of 2 molecular orbitals, namely 1 bonding and 1 non-bonding orbital. Okay. Now, the next question, which of the following is a condition for the combination of atomic orbital? A, is it combining atomic orbitals need not have equal energy. B, combining atomic orbitals must have symmetry as per molecular axis. C, combining atomic orbitals must overlap to a minimum extent. D, for combining atomic orbitals, x axis should be taken as a molecular axis. Okay, what is the correct choice? It is B, that is combining atomic orbital must have symmetry as per molecular axis. Okay, what is the explanation for this? See, combining atomic orbitals, they must have symmetry as per molecular axis, because the corrected statements here, they are the combining atomic orbitals must have equal energy, they must overlap to a maximum extent, and Z axis also should be taken as the molecular axis. Okay. Now, which of the bonding orbital has higher energy when you compare it? So, see, option A is both bonding molecular orbital and anti-bonding molecular orbital have same energy. B, energy of bonding molecular orbital and anti-bonding molecular orbital depends on the situation. C, bonding molecular orbital. D, anti-bonding molecular orbital. The option is D, and D, bonding molecular orbital, because an electron which enters a bonding orbital, it stabilizes the molecule as it is in between the 2 nuclei. But when an electron is entered into the anti-bonding orbital, it needs to pull an electron away from the nucleus. Okay, so the next question, from Na as the number of anti-bonding molecular orbitals and Nb as a number of bonding molecular orbitals. Molecule is stable when Na dash Nb is it greater than, equal to, less than, greater than or equal to. Answer is option C, it is less than. Because when a molecule contains both bonding molecular orbital and anti-bonding molecular orbital, higher the number of bonding orbital, the more the bonding influence and more stable the molecule will be, and vice versa. So, when a molecule has both bonding and anti-bonding molecular orbitals, higher the number of bonding orbitals means more bonding influence will there be, and it will be more stable. Okay. Next question, what is the bond order of oxygen? Is it 3, 2, 1 or 0? Option is B. That is, the formula of bond order is given by half of Nb minus Na, where Nb is bonding orbital and Na is a number of anti-bonding orbitals. So, in oxygen, bond order is equal to half of 10 minus 6, that is half of 4, which is equal to 2. So, when it is 0, the molecule cannot be formed. Just remember, this is an important point. Okay, what do you think is the relationship between bond order and bond length? Is it directly proportional, indirectly proportional? No relation, cannot predict. Answer is option B, indirectly proportional, because the bond length is defined, it is the distance between the 2 atoms in a molecule. So, the bond order will depend on the bond length between 2 atoms in a molecule. So, when the bond length increases, the bond decreases, and vice versa. So, which of the following molecules is not true about paramagnetic molecules? A, it is attracted by magnetic field. B, molecular orbital is singly occupied. C, an example is oxygen molecule. D, it is repelled by the magnetic field. The option is D, it is repelled by the magnetic field, because paramagnetic molecules are attracted by the molecular field and orbitals are singly occupied. Oxygen is an example in this case, where when you take diamagnetic substances, they are repelled by the magnetic field. So, the option is wrong. Okay. So, with that we are coming to a conclusion of this session of important MCQs. So, I will be soon uploading the MCQs from chemical kinetics. You have got to work out so many problems from that as well. So, as always I say, please do like, share and subscribe to my channel, and please do share it with your friends as well. As you all know, NEET 2022 is coming up quite soon. I hope you are all revising the portions and the concepts very thoroughly, and also don't forget to tap the bell icon, because as soon as I post my new videos, you will be able to watch it immediately. Thanks for watching my video.